All right, let's take a look at the next one. So number 11 here, which of the following cannot be used to prove that two triangles are congruent? So two triangles are congruent. Well, up here we saw we had a few different ones. Side, 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 angle, side, angle, side, angle, 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 side, and hypotenuse leg. So which one doesn't belong? Well, hypotenuse leg can be used, so it can't be B. Okay. Angle, angle, side, that can be used. Okay. Side, side, angle. Side, side, angle. We would need the angle between the two sides. Notice here, the angle is not between the two sides. And definitely we can use side, side, side as one of our ways to show that two triangles are congruent. So the one that cannot be used to prove that two triangles are congruent are side, side, angle. Okay? Let's take a look at the next page. All right. Which statement is correct? So we've got two triangles, and we see a bunch of different congruent sides. So we've got side, side, side congruence for these two triangles. Now notice here that all of our letters are represented, the triangle on the left, the triangle on the right, but the difference is the order. So we need to make sure that we have the correct order matching up here. So the order of the corresponding angles absolutely matters. The order matters. Okay, so let's see which ones make sense here. Well, MKD. So MK would have to be congruent to ZU. Well, MK has 1 on there. ZU has 3. Because the order matters, it can't be A. DM, okay, has 3 here. PU has 2. Can't be B. KM has 1, PU has 2. Can't be C, it's gotta be D. But let's just verify here. So DK has 2, UP has 2. KM has 1, PZ has 1. Okay, so that means that the third side would have to automatically be congruent by side, side, side congruence because we've already got 2. So this is why it's D. Let's take a look at number 13. Quadrilateral ABCD is shown. What must measure of angle BCD, so angle BCD, that's this angle here, okay? What must be the measure of that angle for this actually to be a parallelogram? Now this is a kind of an interesting problem here. So with our problem for this one, we need to be able to prove that the opposite angles in a parallelogram are congruent. Well, if we're looking for angle BCD, we have no information because angle C and angle A, if it's a parallelogram, would be congruent. But this has no information either way. But realize the opposite angles here, angle B and angle D, could be congruent. So how do we show that these are congruent? Well, if they're congruent, it means that they're equal. Okay? If angle B is equal to angle D. So let's set these expressions equal to each other. So we've got 5a minus 3 equaling 4a plus 9. So we're going to show what a is here. So let's get the a's on one side and all of the constants on the other. So let's subtract 4a from this side and the other side. Okay, so since we got rid of the 4a's, let's move the 4a's to this side. Let's move the negative 3 to the other side by adding 3 to both sides. Okay, in this particular case, what are we going to have? Well, 5a minus 4a, that's just a. The 3's cancel out, so I'm just left with a on this side. The 4a minus the 4a cancels here. 9 plus 3 is just 12. So we know that a is equal to 12. Okay, this is helpful. But we're not done. We need to figure out what that angle is. Okay, so what can we do with this? Well, we know that angle D, This angle D is 4A plus 9. We could also use B, but I'm right here next to D, so let's use D. So we know that angle D, okay, would be 4 times A plus 9. Well, we know that A is 12. So 4 times 12 plus 9. So let's see, angle D should be a what? Let's grab our calculator here. Turn that on. So we've got 4 times 12 plus 9. So 4 times 12 plus 9, and that's going to give us 57. So we know that that angle D is 57 degrees. Okay? Well, we still haven't answered the question yet. Angle D is 57. But realize once again, if this is a parallelogram, think of these two sides as being parallel to each other. This CD is now transversal. These are same side interior angles. Same side interior angles are supplemental. That means that if I took angle C plus angle D, it would have to be equal to 180. Well, we already know that angle D is 57. So angle C plus 57 equals 180. Subtract 57 from both sides. Angle C, 180 minus 57, 180 minus 57, is going to be 123 degrees. Okay, so angle C is 123 degrees. Okay, that answers the first question. Okay, now what must be the values of x and y for triangle parallelogram ABCD to be a parallelogram? So once again, if we're looking for x and y, what we can do is just realize that, well, one of these two sides are equal to each other. Those two sides are equal to each other. So set those equations equal to each other, or those expressions equal to each other, right? So let me just put a little line here. So we've got 5x plus 4 is equal to 7x minus 2. So we're going to solve for x here. And then for our y, we're going to have 2y plus 1 is equal to 3y minus 5. Okay? So solving this, let's get rid of our 7x. Let's subtract 7x from both sides. Let's subtract 4 from both sides. So we have a 5x minus 7x is a negative 2x. Getting ahead of myself here. So it's a negative 2x. The 4's canceled. On this side, I've got a negative 2 minus a 4. So that's a negative 6. Divide both sides by a negative 2. And x is 3. Okay? So x is 3, but what's y? Now y, well, once again, let's get all of our constants on the one side, variables on the other. Let's subtract 3y from the left and the right. Let's subtract 1 from the left and the right. In which case, 2y minus 3y is a negative y is equal to a negative 5 minus a 6. Well, that's just a negative 6. But we're not looking for negative y, we're looking for positive y. So if a negative y is a negative 6, then that means positive y is a positive 6. Okay? Last one on this page. Number 14. For a dilation with a scale factor less than 1, how do the angles and side lengths of the pre-image relate to the angles and side lengths of the image? So we got to remember here that we always start off with our pre-image, and then in this case, after a dilation, it becomes the image. Okay, so we would apply that scale factor to get from one to the other, right? So we would apply that scale factor. Well, in this particular case, our scale factor is less than 1. So that means what we end up with is we end up going from a larger shape to a smaller shape. So what does this tell us? Well, we know that for dilations, okay, angles stay the same. Angles are congruent. Okay? Angles are congruent, but it's asking how did the pre-image relate to the side lengths of the image? Well, it was big, it got small. But how does this compare to that? The side lengths were larger than they were small. Okay? Now this is an oddly worded question. Okay? Because it's asking us to compare the pre-image to the image. Not necessarily what happened to it, that we went from larger to smaller, but how did the pre-image that was larger, how did that compare to the image that was smaller? The side lengths were larger. Okay?